Standard form or vertex form of a quadratic function with vertex hk, f of x equal a times the quantity x minus h squared plus k. This is called the vertex form because it's easy to identify the vertex. The vertex will be h comma k from this form. Okay, so if, first example, f of x equal x squared minus 8x plus 15. If we want, we can use the method of completing the square to write this in the vertex form. Right now it's in the intercept form. So we want to take half the coefficient of x, half of 8 is 4, and square it. 4 squared is 16. So we want to add and subtract 16 to make this into a perfect square. And then this first three terms is a perfect square. We can factor that. X times x is x squared. Then we need two numbers to multiply to 16, add up to negative 8. And the two numbers are negative 4 and negative 4. And you can check with the for-all method. X times x is x squared. Outer product is negative 4x. Inner product is negative 4x. Combine those, you get negative 8x. Last times last, negative 4 times negative 4 is 16. And then these last numerical terms, these last two numerical terms, we can do the computation there. Negative 16 plus 15 is negative 1. So f of x is equal to the quantity x minus 4 times the quantity x minus 4 minus 1. We can write this more compactly with exponents. So this will be x minus 4 times the quantity x minus 4 is the quantity x minus 4 squared, and then copy the minus 1. To exactly match this, I mean, you could leave it like this if you want. If you want to exactly match the form, technically you need a plus here. Our form has a plus k there, here. So if you want to exactly match the form, you could put plus a negative instead of just negative 1. And if there's no number in front of the x squared, it's understood to be 1. So f of x equal 1 times the quantity x minus 4 squared plus a negative 1. And that enables us to identify the vertex hk would be 4 comma negative 1. And because a is positive, that means it's opening up. Okay. We can. Okay, so the equation, we can still identify it, even though this is not the intercept form. It's still helpful to identify the intercept. Y-intercept would be f of 0, which is, replace x by 0, will be 0 minus 4 quantity squared minus 1, which is 15. And the x-intercepts, you set f of x equals 0, so x minus 4 quantity squared minus 1 equals 0. Add 1 to both sides, x minus 4 quantity squared equals 1. Take the square root. Well, 1 has two square roots, either positive 1 or negative 1. So you have x minus 4 equal plus or minus 1. And then add 4 to both sides to isolate the x. X equals 4 plus or minus 1. And then split up the plus or minus. X is equal to 4 minus 1 or 4 plus 1. 4 minus 1 is 3. 4 plus 1 is 5. And now we can sketch the graph. Okay. So the y-intercept 0, 15. You have the two x-intercepts 3 comma 0 and 5 comma 0, and the vertex 4 comma negative 1. And so we can plot those points. 0, 15, that's 0 left to right at 15, that's the y-intercept. 3 comma 0, 3 to the right up or down 0. 5 comma 0, those are the two x-intercepts. The 0, 15 is the y-intercept. And then the vertex 4 to the right, down 1. And then connect the dots, and that's our graph. Okay, second example. Suppose the profit in dollars of a paint manufacturer selling X gallons of paint is given by the equation P of X equal negative 0.1 X squared plus 4X minus 30. And we want to write this in standard form or vertex form. First of all, we want to factor out the coefficient of x squared, negative 0.1. So inside parentheses, we'll have x squared minus 40x. And then we want to make this into a perfect square. So half of 40 is 20. 20 squared is 400. So we want to add and subtract 400 to complete the square. The 400 that I'm adding is inside parentheses with a negative 0.1 on the outside. So really I'm adding negative 0.1 times 400. So I have to, in order to make the equation equivalent, I have to add positive 0.1 times 400. And then we can factor this using trial and error. X times x is x squared. And then we need two numbers to multiply to negative positive 400, add up to negative 40. And the numbers that work are negative 20 and negative 20. If we do this computation here, 0.1 times 400 is 40, 40 minus 30 is 10. Okay, so we can write this quantity x minus 20 times the quantity x minus 20 more compactly, x minus 20 quantity squared, and then we can identify A, H, and K. So A is the coefficient of the squared term, and because A is negative, that means it's going to open down. HK is our vertex, so it'd be 20 comma 10. That represents the maximum profit. Okay, so even though this was the vertex form, we can still it's still helpful to get the intercepts. Y-intercept occurs when x is 0. P of 0, negative 0.1 times 0 minus 20, quantity squared plus 10. And this comes out to be negative 40 plus 10, which is negative $30, representing the overhead cost. And to get the x-intercepts, we want to set P of x equal to 0. So negative 0.1 times the quantity x minus 20 squared plus 10 equals 0. Add negative 10 to both sides. Trying to isolate the x, divide by negative 0.1. That gives you x minus 20 quantity squared equals 100. Take the square root of both sides. 100 has two square roots, plus or minus 10. Add 20 to both sides, so we have x equal plus or minus 10. And then split up the plus or minus. X is 20 minus 10, which is 10, or 20 plus 10, which is 30. So the x-intercepts are either 10 or 30 gallons of paint. And now we can sketch the graph. So we're given the y-intercept 0, negative 30, two x-intercepts 10, 0, and 30, 0, and the vertex 20, 10. Plot those at 0 left or right, down 30. That's the overhead cost. The two break-even points, 10 to the right, up or down 0, 30 to the right, up or down 0, and the maximum profit is 20 to the right, up 10. That's 20 to the right, up 10. And that concludes this presentation.